We are using the traditional method to do a hypothesis test about the difference between two means. It says, according to Nielsen Media Research, children ages 2 to 11 spend an average of 21 hours and 30 minutes watching TV, and teens 12 to 17 spend an average of 20 hours and 40 minutes watching TV. Based on the sample statistics shown, is there sufficient evidence to conclude there is a difference in the average television watching times between the two groups? And they want you to use an alpha of 0.1. So we're going to call the children 1 and the teens 2, so that each one of these will be labeled like this is X bar 1, this will be X bar 2. This will be your sample size 1, sample size 2. I do want you to be careful on this middle part right here, because they gave you the variance instead of the standard deviation. And so in the formula, the variance is the square of the standard deviation. So this is already squared. This is sigma squared. It's number 1. And sigma squared. It's sigma number 2, but it's squared. So it's already squared because we have the variance. The hypotheses. We start out by saying that mu1, the children, are equal to mu2, that there's no difference between the amount of time that they watch TV. And you can write it like this or like this. The no difference means that there's 0 difference between them if you subtract. We generally write it like this. The alternative would be that there is a difference, that they're not equal to each other, and so that's the claim here. This is the claim, that there is a difference. They're not equal to each other. This is a two-tailed test, and we will be using the t-table for this. The reason that we're using the t-table to get the two critical values is because we only have a sample variance and a sample standard deviation. It goes back to this idea right here. If this was population, we'd be using the z-table, but since it's sample, we're using the t-table. I'm going to bring up the t-table so you can see it. On the t-table, the left-hand column is degrees of freedom. You actually have 2 sample sizes when you do a comparison of the means. Usually you use the smaller of the degrees of freedom. Our sample sizes both happen to be 15, so we'll be using line 14. But if they were different, like say one of them was 20 sample size and the other was 15, you'd use the smaller of the degrees of freedom. But ours are exactly the same, so 14. The alpha that we want is 0.1. We're on a two-tailed test, so it's 2.977. And so you have plus or minus 2.977, 2 critical values, 2 critical regions. We're going to calculate the test value. This will be a t, but it's calculated the same. You take the mean from the children minus the mean from the teens. Now remember, normally right here, we put the standard deviation and we square it, but we already have the variance, which is the standard deviation squared. So we don't need to square it again. This is also the variance over here, the 18.2. It's already squared. When I put this in my calculator, I'm getting 2.601. And then when I look at where that test value is on this picture, it's right over in here somewhere. It's not in this right critical region. It's not big enough to be in there. And so when we make our decision is to not reject because it's not in a critical region. So we do not reject the null hypothesis because the test value is not in a critical region. We are not able to reject a null. We're not able to say this is incorrect, reject it. So we are not able to say that the alternative is true, and so we are not able to support this claim. We can't reject the null. If we could have, we would have been able to support this claim, but we can't. So we are not able to support the claim. So we're not able to support the claim that there's a difference in the amount of time that children watch compared to teens.